There's a point on the curve near 2 comma 4 with x coordinate 3. Use the line tangent to the curve at 2 comma 4 to approximate the y coordinate at this point.
Okay, so what this is basically saying is I have this ugly curve. How you make the curve does not matter. So go ahead and make a curve however you want. You can mimic my curve if you want to. So it's saying, hey, there's my curve. Because to me, the visuals make a lot more sense. And then it's telling you, I'm going to give you dy over dx, which is representing our slope, right? So our slope is basically saying, if I put a dot here, it'll give me a positive slope. If I put a dot here, it'll give me a horizontal slope. If I put a dot here, it'll give me a slope. Oh, that's not the right way, this way. So this is a slope formula. So we have two formulas, one the curve and one that calculates the slope. Are we good with that? Okay? So with that said, part A says, find, is there a point near 2, 4? So 2, 4 is going to be x comma y with the x coordinate of 3 and use a tangent line. So we have to go ahead and first find the tangent line. To find the tangent line, the only issue is, you know how we have our equation is y minus y1, I'm recording, is equal to the slope times x minus x1, correct? So the only thing I'm missing is my slope. So what I have to do is I need to plug in 2 comma 4 in here to find the slope. So let's go ahead and do that. Part A. So we have y minus y1. My y1 is 4 given. Is everyone good with that? That is given to us. Is equal to, I'm going to leave a blank for the slope. X minus, what is the x value given? 2 given. So it's literally like 3 item has been spoon-fed to you. And then our slope, which is also determined by dy over dx. And you have the equation up there on somewhere, so we have 2 times, what is the value of x that we're going through? 2 over 3 plus 4 times, what's the y value? 4. Notice this part is non-calc, which is not a problem. So we have negative 4. And we know this is going to give us 16, and 16 plus 3 is how many? 19. So I'm going to write negative 4 over 19. And now it's just a matter of distributing and combining like terms. And it looks like they gave us an x coordinate. This is my 3. And they're asking us for the y coordinate, correct? So if I plug that 3 in here, can I then solve it for the y? Yep. So let's plug it in. So we have y minus 4. And then just leave everything as it is. Just plug in the 3. And to avoid more work, I'm going to write out y equals. Because it is time consuming. Would you agree? That's going to give us 1. What's up? I forgot 19, right? Yep, thank you. Would you agree 3 minus 2 is simply 1? Okay, so if I take 1 times negative 4 over 19, it is still itself. And then I'm going to do my algebra 1. If I move the negative 4 over, what operation do I need? 4. And then I want to use common denominator. Obviously, I only have one common denominator. So someone do 19 times 4 to the side, or I will do 4 times 10, and then 4 times 9 and combine that. It'll be less than 80. What is 40 plus 36?
76.
Thank you, 76. And that will combine to be 72 over 19. Here's the good news, though. If you don't want to combine or use the common denominator, it's okay. If you don't want to go all the way down to 72, it is also okay. So here's a breakdown of our steps. Plug in your x and y value of 2 and 4, and getting negative 4 over 19 is 1 point. And then show in the steps, literally you could stop anywhere. You could stop here, here, or here, and you get 1 point. Because y'all remember on the FRQs that said you don't have to simplify all the way? You could stop, okay? That's the same idea here. Okay, was that actually hard? I think it was a wording. Too many words, right? Okay.
No, I did it.
I'm going to move on since I'm recording. Let's go on to part B. On part B, Charlie, go ahead and read.
The horizontal line minus 1 tangents the curve. The reason for your answer.
Okay, so it's saying the horizontal line y equals 1. Is that tangent to the curve? So if I were to kind of visualize this, this is what I'm hoping to see, and then I'm going to show you what we're not going to see. Okay, so it's saying, given a curve right here, can I make a horizontal line at y equals 1? Or y equals, was it 1?
Yes.
To get a horizontal tangent, and a horizontal tangent means our slope is 0. That's what I'm hoping. Hold. That is my hope. So let's see what that all means. Let's start by writing out our slope equation. You don't have to rewrite it, but it's kind of a good practice. And then I have 3 plus 4y. So for this slope to be a 0, I only care for the top to become a 0. Do we agree on that? What's up? Yes. So we only care about the top. So I'm going to circle my top and say, all I care about is that the top is equal to 0. The bottom number could be any number as long as it's a non-zero. So I'm going to say negative 2x is equal to 0. What is my x then? When I divide it by negative 2, what do I get? 0. Okay? And they also gave us y is equal to what? The horizontal tangent at what number? 1. And that's when my slope is going to be 0. So let's actually test this out. So the first thing I'm going to test is when something has a tangency on a line, it's touching at one point, correct?
Yes.
So I have to first figure out, is my point on the line first? Because if it's not on the line, it's just made up.
So you just plug in x and
We
y.
plug in this one and this one into the original equation. So our curve equation was my 0 squared plus 3y, which is 1, plus 2, 1 squared, must equal 48. Because if the left and the right does not match, it's not on the line. Are we okay with that? Okay? So just by looking at this, we can do some quick math. I know that's going to give us 0. I know that's going to give us 3. And that's going to give us what? 5? Is 5 equivalent to 48?
No.
No. So here's the actual drawing that I'm just going to approximate. My drawing is not going to be accurate, okay? So the actual drawing is doing this. It's saying I have y equals 1, and my point here at 0, 1. So can that even be a point of tangency? No. Cannot. So then our wording is going to be the point 0, 1 is not on the curve. And then we would have to rephrase what we have on here. So I would say, let's see, the horizontal tangent. So I'm going to use this phrase right here. The horizontal tangent y. And then say blah, 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 whatever that means. So the horizontal, I forgot E. Look at my spacing, it's awful. What is this? The horizontal, okay. Horizontal line, y equals 1, is not tangent to the curve. So the first drawing is what we were hoping for, then we could answer everything about it. And then the second drawing is what the reality is. It's not, it's like floating up in the air. Okay? To me, the visual makes a lot more sense. And now let's go on to part C that talks about our vertical lines. And I'm going to give you also a visual on this one that's not going to be accurate, but we can still kind of understand the idea of it. So for the vertical line, let's see, Nev, go ahead and read part C.
The curve intersects the positive x-axis at the point root 48, 0. Is the line tangent to the curve at this point vertical? Give a reason for your answer.
Okay, if the line tangent to that is vertical, that means it is undefined, correct? So we're hoping to see 0 on the bottom. Good? So then, let's see what's happening here. I'm going to give you a visual. So my visual is, I'm hoping you have this somewhere on your table, so I'm not referring back to it. So my visual is going to look like, I'm hoping I have, I'm just making this up. I have a curve like this, and I have a point right here that's at radical 48, 0, and I'm hoping that to be a vertical line. Let's see if that actually does happen, because it could be another no, right? So for that to happen, since they already gave us that the point is already on radical 48, 0, can I plug this into our slope form? Yeah, we already have x and y, right? Let's go ahead and plug it in. So our slope was dy over dx. And I'm just going to rewrite the whole equation again because I feel the need to. Something about writing it in a vertical manner does help. So we have negative 2 times radical 48 over 3 times, and we're looking at 4 times 0. And just by looking at this, we know we have a positive or negative slope here. What kind of slope do I have? Is it a negative slope? So let's see the visual. What's actually happening is this. And again, this is simply my visual. So radical 48, 0 is actually here. And our tangent is a negative slope. That's what's happening. So it's, the question asked us, is there a line tangent that is vertical? So we have a negative slope, right? So let's go and define this. We have a negative slope. Writing more than you need is always good, okay? Writing? Okay. So I'm gonna write on here the slope. If the slope is found, is that defined or undefined? It is defined. There is a value. Slope is defined. So the tangent line, that's a line by the way, let me rewrite this, is not vertical at the point, radical 48 comma 0. What if you wrote instead, because you forget the word define, and say it is not undefined? Is that okay? Yeah, double negative. I'll take it. If I were the AP grader, I'll give you full credit on that one. So our point breakdown on this one, only because you were plugging the given point into the slope, which technically is simply substitution, all that is 1 point. So it's all about how much work did you put in. Not as much, 1 point. Okay, our last one, part D, is the part that I wanted you guys to be very comfortable with, because we did a bunch of related rates. When we did related rates, we always said dr over dt, dd over dt, and so on, correct? So let's kind of recall. Jackson, go ahead and read part D.
For time at t 0, particles moved along the grid on that equation. Y over 3 plus 2xy equals 24. At the instant the particle is at the point 42, the y coordinate of the particle position is decreasing at a rate of 2 units per second. At that instant, what is the rate of change of the x coordinate of the particle's position with respect to time?
Very wordy, right? Let's break this down. We know the point x and y is given. Someone's not writing with a water bottle. I see you. And then we are going to derive this implicitly. And then it says the y coordinate is decreasing at a rate of 2 units per second. So what I know right now is this. I know the y coordinate dy over dt is decreasing because it's going down. Am I simply going to write 2? If I just write the slope of 2, that means it's going up, right? So because it's decreasing, I'm going to say it's got to be negative 2. That's a common mistake that kids make. You'll get everything right except that part, okay? And then it says we're looking for dx over dt. That's our goal. And they gave us a coordinate 4, 2 for x, y. So I'm going to start off by writing those givens on the top, just because it's going to be helpful. So it is given that I have 4, 2, which is my x, y. It's also given that the rate of the y value is negative 2, and we are looking for dx over dt. That's our question mark. And then the way I'm going to write out the original equation, let's write out the understood one as needed. So we have y cubed plus, the next part is product rule, right? So we have 2x, someone's not writing, because this part is the easy part. Let's go ahead and derive this implicitly. What is the derivative of y cubed? 3y squared, and then we need dy over dt. For everything that's with respect to time, we have to write that letter over dt. For the next one, let's use product rule. So let's kind of recall. We derived the first, which is what? 2, and I need dx over dt. And I keep the second one that I'm going to leave it as times y. What operation, if y'all remember? Plus. And then I keep the first one, which is 2x. When I derive the 1y, can I just write 1 and dy over dt? Yep, that 1 is like pretty much not necessary, but that's okay. Is equal to 0 because any constant, 24 derivative is 0. So now I'm going to go ahead and circle all the pieces that I know. Don't we know the y value? Yeah? Don't we also know the dy over dt? We know this y value, we know this x value, and we know this y value, dy over dt. And notice the only variable remaining is dx over dt. Do we see that? So that's a calculus part. After that, it's pretty much algebra. So let's go ahead and substitute in. So we have 3, and just for teaching purpose, I'm just going to plug everything in. Some of you guys may want to do this in your head. That's up to you. But I would not risk that, especially if you know how to do it. And then y is 2 plus 2, x is 4, and then we have dy over dt is negative 2 is equal to 0. Okay, let's do everything in one go as big chunk. What would all this give me? 3 times 4 times negative 2, is it? Good, negative 24, thank you. For the next one is just simply 2 times 2, which is 4. Dx over dt, bless you. What would all this give me right here at the end? Minus something. Very good, minus 16 is equal to 0. And then what I want to do is two things at the same time. Let's combine these two together and move it over to the other side with the opposite sign. So when I do, I get 4, bless you, dx over dt. Isn't that going to give me 40 on the right side? And then when I divide that by 40, what do I get? How many? 40 divided by 4? 10. And for this one, did they give us a units? If they didn't, just write out units per second. Okay, there was a lot more work on this one, right? We had to use implicit, know when to plug it in, and know what to plug it in. So here's what's going to happen. Knowing how to derive implicitly, that's going to give you 2 points. That's a big deal. We should all get that, right? And then after that, plugging things in, applying algebra all the way down, it's going to give you another 2 points. So on A, B, C, and D, did you have to know how to do A, B, or C in order to do D? Not at all. And that was 4 points right there. Big deal.